Hello and welcome to Explore Azure Pipelines and Agent Pools. I'm Andrew Conniff, a Microsoft technical trainer specializing in data and AI. And in this video, we're going to explore Azure Pipelines and understand how they enable continuous integration and continuous delivery in modern DevOps practices. So let's get started and jump right in. A pipeline in DevOps is an automated assembly of processes for delivering software. It streamlines the process of building, testing, and deploying code, so changes from developers can flow smoothly and reliably into production. By automating these steps, pipelines help teams deliver updates faster and with fewer errors, making the whole development process more efficient. Pipelines require infrastructure to allow secure orchestration of host machines and processes to run on the code. Overall, the pipelines make it easier for teams to deliver high-quality software to customers with confidence. Azure Pipelines is a cloud service that automates building and testing your code, making it easier to deliver software quickly and reliably. It works with any language or platform. It integrates with GitHub and supports deployments to various targets like containers, virtual machines, and cloud services. This helps teams streamline their development process and improve code quality efficiently. Let's break down the essential building blocks of Azure Pipelines. At its core, a pipeline is like a roadmap for getting your code from development all the way to deployment and production. It's made up of stages, jobs, and steps. So think of the stages as major milestones. Jobs as a set of tasks that run together, and steps as the individual actions that make things happen. Triggers kick off our pipeline or start our pipeline, whether it's a code push, a scheduled time, or another event. Each job runs on an agent, which is just a piece of software that does the heavy lifting, like building or deploying your app. As your pipeline runs, it produces artifacts. These are the files or packages that get handed off for deployment or further testing. This automation means you can deliver updates faster, catch errors earlier, and ensure your software is reliable and ready for your users. We'll dive deeper into each of these concepts as we move through the course, but for now, keep these definitions in mind. They are the foundation for everything you'll do with Azure Pipelines. Now let's talk about managing pipelines and agent pools. Let's look at the two main types of agents we can use in Azure Pipelines: Microsoft hosted and self-hosted. So Microsoft hosted agents are the easy button. Microsoft takes care of all the maintenance and upgrades for you. Every time you run a pipeline, you get a fresh virtual machine, so you don't have to worry about cleaning it up after previous jobs or keeping the software up to date. The trade-off is that there are time limits on how long your jobs can run. On the other hand, self-hosted agents give you more control. You are responsible for maintaining and updating the agent, but you can install any software that you need, and there are no time limits on your jobs. Self-hosted agents can run on Linux, Mac OS, and Windows, or even inside a Docker container. So if you need custom tools or longer running jobs, self-hosted agents are the way to go. Let's talk about the different types of jobs we can run in Azure Pipelines. There are four main types: agent pools, container jobs, deployment group jobs, and agentless jobs. Agent pool jobs run on agents in a pool, which is the most common setup for building and deploying our code. Container jobs are similar, but they run inside of containers. They're great for isolating environments or matching production setups. And deployment group jobs run on specific machines grouped together, often used for deploying to on-premises servers. And finally, agentless jobs run directly on the Azure DevOps server and don't require an agent to run at all. Understanding these job types helps us pick the right tool for our pipeline. For example, if you need to build and test in a consistent environment, container jobs are a solid choice. If you're deploying to a group of servers, deployment group jobs make that process much smoother. And for tasks that don't need a dedicated agent, agentless jobs keep things simple. Choosing the right job type ensures your pipeline is efficient, reliable, and tailored to your project's needs. Imagine you have a team of machines ready to help with building and deploying your code. You can organize these machines, called agents, into groups known as agent pools. An agent pool acts as a sharing boundary, letting us decide which projects can use which agents. This means you can efficiently allocate resources and avoid bottlenecks when multiple projects need to run jobs at the same time. In Azure Pipelines, agent pools are scoped to your entire Azure DevOps organization, so you can share a pool across different projects. This flexibility is especially useful for larger teams or organizations that want to maximize the use of their build and deployment infrastructure. By setting up agent pools, you ensure that your pipelines run smoothly and that your team's resources are used effectively. Azure DevOps offers a variety of Microsoft-hosted agent pools covering common operating system images, Windows, Ubuntu, and Mac OS, so you can match your pipeline's needs without managing the machines yourself. The key idea is that teams can pick a ready-to-use VM image by label in YAML, run builds and tests, and move on. No setup, patching, or cleanup required. These images update regularly, so the latest labels map to current platform versions, and the definitive list can be checked in the documentation. Use agent pools to share a set of build deploy machines across projects or reserve them for just your team. If you're on an infrastructure team, you might set up a central pool that multiple projects can draw from. If you're on the app team, you might keep a dedicated pool for your own workloads. The idea is the sharing boundary. Pools let you control when you can queue jobs and to which agents, preventing bottlenecks and keeping high priority pipelines moving. In practice, that means that you can have Pool A serving projects A1 and A2 with separate queues, while Pool B serves another collection. Clear, predictable resource allocation without conflicts. When working with Azure Pipelines, communication between the agent and the Azure pipeline is essential for running jobs, reporting logs, and updating the job status. The agent is a piece of software installed on a machine, either on-premises or in the cloud, that initiates all the communication with Azure Pipelines. This means that the agent reaches out to the pipelines, not the other way around. This ensures a secure and controlled connection. All messages sent from the agent to the Azure Pipelines travel over HTTPS, which is the same secure protocol used for online banking and shopping. And this setup helps protect sensitive build and deployment information as it moves between your infrastructure and Azure's cloud services. A key benefit of this communication model is flexibility. Agents can run behind firewalls on your own servers or on cloud-based machines, and if they can reach Azure Pipelines over port 443, the standard port for HTTPS, they can participate in your automated workflows. This design allows organizations to maintain strict security controls while still leveraging the power of cloud-based DevOps automation. Whether your agent is running on a secure internal network or in the public cloud, you can confidently automate builds, tests, deployments, knowing that all communication is both agent-initiated and encrypted. When setting up Azure Pipeline agents, it's important to think beyond just getting them running. There are several key considerations that help ensure that your pipelines are secure, reliable, and efficient. Agents need to securely identify themselves to Azure Pipelines, often using personal access tokens. These tokens act like digital keys, allowing agents to communicate and perform tasks while keeping your system safe. You'll also need to decide whether your agents run as interactive processes, which require a user session, or as a service processes, which run in the background and are generally preferred for automation. Keeping your agent software up to date is another best practice, as updates often include important security and performance improvements. When working with Azure Pipelines, managing who can do what with your agent pool is crucial for security and operational efficiency. Each agent pool has defined roles: reader, service account, and administrator. That determines what actions a team member can perform. For example, someone in the reader role can view the agent pool and monitor agent health, making it ideal for operations or operators who need oversight but not control. The service account role allows members to use the organization's agent pool to create project-specific pools, streamlining setup without granting broad permissions. The administrator role is the most powerful, enabling users to register and unregister agents, manage all roles, and oversee the entire agent pool. The person who creates the agent pool is automatically made an administrator, ensuring there's always someone with full control. Let's move to a demonstration of creating and configuring Azure Pipelines. Starting in Azure DevOps, Let's configure a pipeline in Azure Pipelines. First, we identify where our code is. If we have set up a secure connection to GitHub, we can choose that connection here. Our code is in Azure repositories, so we don't have this connection set up. Let's choose that. And here we can pre-populate our file with tasks and stages needed for different deployment types. We already have a pipeline YAML, so we'll choose that one. And select Continue to the next step. This YAML does not have a trigger configured, so we will add one here for the main and release branches. Now let's review our pipeline. The variables section allows us to set reusable values for the rest of the file and make adjustments in just one place. And here we see the stage declaration. This is a build stage. And we see that this job is using Ubuntu latest for its tasks. Notice we are deploying our resources using a bicep task. We're implementing PowerShell and Docker commands to build and push the image artifact for deployment later. Now we can tag our image here, and we're providing the build.build ID as the version. The push Docker image task then pushes the tagged image, which will be unique for each pipeline run. In GitHub or GitHub Actions, the process is similar, but runs in GitHub workflows. Creating a workflow is a familiar process of either creating an empty workflow or choosing from pre-populated workflows. Here we see a basic starter YAML for our GitHub workflow actions. You can choose actions from the marketplace. And here we are looking for a Docker action for our workflow. When ready, we just copy it to our file. We can continue adding to our tasks and configuring our file until it's finished. If you'd like to go deeper and run the AZ-400 lab exercises using your own accounts and subscriptions, you can find the self-paced labs on GitHub at Microsoft Learning /MSLearn-DevOps. And if you prefer structured guidance, you'll also find options for instructor-led AZ-400 training with live labs and expert instruction on Microsoft Learn at the AZ-400 course page. That concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.